All right, guys, here is the start of section 2.5. Now we are hardcore into proofs now. This section we're going to talk a lot about segment proofs, and the next section will be angle proofs. Same concept, just I'm not sure why your book separates them into two different sections, but that's the way they do it. All right, so let's do a couple vocabulary words, not bad. So a proof it's a logical argument that uses deductive reasoning to show that a statement is always true. Okay, remember, deduct is we're proving it. So there's no stone left unturned. We are going to go step by step by step and show why something has to be true. All right, a two-column proof, guys, that's what we were doing yesterday. We start with a T-chart. And the left-hand column is generally for the true statements. And the other is for the reasoning. I'll put reasoning of the true statements. Last but not least, theorem. Guys, we are going to be encountering a ton of theorems this year. Theorems are like the rules of geometry. So you have to know them. So anytime you see a theorem, you need to make a mental note and remember it. So a theorem is a statement that can be proven. We can write a proof for every theorem out there. All right, our first few examples are going to be rather easy. So we're just going to follow along. They've given us the left-hand side of the equation. All we have to do is fill out the right-hand side. So we're given that AC equals AB plus AB. Okay, that's just given. That's our reasoning. All right, now we need to look here. Now it says that AB plus BC equals AC. So we need to figure out how they came to this conclusion. Okay, well, if we look at the diagram, AB plus BC equals AC. Yes, it sure does. If you remember back from chapter 1, that was called the segment addition postulate. So anytime we add two segments that are side by side, it equals the big one. All right, now AB plus AB equals AB plus BC. So you're saying what? And this one kind of is a little hard to see, so I'm going to highlight. Here's an AC here, here's an AC here. Okay, so if both this in blue equals AC and this in blue equals AC, doesn't that mean that these two have to equal each other? If A equals B and B equals C, then A equals C? Well, that's what we did right here. Okay, AB plus AB equals AB plus BC. So this would be the transitive property of equality. Now to get from step 3 to step 4, all they did, guys, is they subtracted AB from both sides of the equation and then simplified. So this would be the subtraction property of equality. All right, this one here is kind of the opposite of what we just did. So now the right-hand side of the equation is written, and we have to fill out the left-hand side. All right, so the first thing is our given. Well, our given is right here. So I can say the measure of angle 1 equals the measure of angle 3. Okay, now when you're doing this, understand what's going on. Okay, so 2 says measure of angle EBA, so this angle here is equal to 2 plus 3 put together because of the angle addition postulate. That is a true statement. When you're adding angles side by side, it equals the big one. That's the angle addition postulate. Okay, now this one, notice statement 2 and statement 3 are the same, except this 3 turned into a 1. Okay, well, if you look back at number 1, it says angles 1 and 3 have the same measure. So if they're the same, can't we substitute 1 in for 3? Yes, we can. All right, now it says EBA equals what? And it's telling you you're using the commutative property of addition. So if you go back to the community property of addition, it says A plus B equals B plus A. So we can just flip the order in which two things are added. So we're going to take this, and all we're going to do is we're going to flip these two because this commutative property of addition tells us to. So it's going to be measure of angle 1 plus the measure of angle 2. All right, now we're going to be using the angle addition postulate. Anytime you see angle addition postulate, refer to the diagram. Okay, so measure of angle 1, which is right here, plus the measure of angle 2, which is right here, should be equal to this big angle right here. So it'd be the measure of angle CBD. We got that straight from the diagram. Now once again, we have measure of angle 1 plus measure of angle 2, measure of angle 1 plus measure of angle 2. Two things that are equal to the same thing are equal to each other. Well, both measure of angle EBA and measure of angle CBD are equal to angle 1 plus angle 2. So that would be the transitive property of equality. All right, let's do a full-blown example. We have no help with this. We have to fill out both sides. Okay, but we can do it. All right, so measure of angle 1 plus the measure of angle 3. That's what's given to us. The two of them are equal. Measure of angle 1 equals measure of angle 3. That's given. We want to eventually get to measure of angle DBA is congruent to EBC. Now, I know it's hard to see on your black and white paper. This is point D and this is point E. You might want to write that in because if I remember right from last year, it was hard to see with the yellow. All right, so I'm going to look at this a little closer. How do I go from measure of angle 1 to the measure of angle DBA or the measure of angle EBC? Well, I can see that the measure of angle 1 plus the measure of angle 2 equals measure of angle, what, EBC? And likewise, I can also tell you that the measure of angle 2 plus the measure of angle 3 equals what angle? Measure of angle DBA. And both of these are true because of the angle addition postulate. All right. Now, anytime we're given that two things are equal, in the back of our mind, we should be thinking substitution, substitution, substitution. So I'm going to take this statement right here. Measure of angle 2 plus measure of angle 3 equals measure of angle DBE. Can we substitute anything for angle 3? Notice that measure of angle 1 equals to measure of angle 3, so we can substitute the measure of angle 1 in for the measure of angle 3. So that's what I'm going to do. Measure of angle 2 plus measure of angle 1, I substituted here, equals measure of angle DBA. And that's just the substitution property of equality. Okay, now some of you are looking thinking, well, why did we do that? Okay, well, notice we're close. EBC is 1 plus 2, and this one's 2 plus 1. So couldn't we flip the order of these? Couldn't I say this is measure of angle 1 plus measure of angle 2 equals measure of angle DBA? And isn't that the commutative property of addition? Now we're in business, guys. So now notice, measure of angle 1 plus measure of angle 2, measure of angle 1 plus measure of angle 2. So if both of these angles are equal to the measure of angle 1 plus measure of angle 2, they have to be equal to each other. Okay, so now I can say the measure of angle EBC is equal to the measure of angle DBA, and that's the transitive property of equality. Two things that are equal to the same thing are equal to each other. Now we're almost done. Almost, but not quite. Notice, remember, we have to be very exact with proof. What we wanted to prove that DBA is equal to EBC. We have them flipped. So all I'm going to do is flip them. Measure of angle DBA equals the measure of angle EBC. And do you remember what property says we can flip what's on each side of the equal sign? It's the symmetric property. And we are done. All right, I want you guys to take a minute, try to do this one on your own, and then we'll come back to it and I will go through it with you. All right, hopefully you've done it and you got through it, but if not, we'll go over it. So T is the midpoint of SU, guys. You should have gotten that one. That's just given to us. Now the goal is to go through here and make sure you understand it. All right, so T is the midpoint, that's given. Now we all know that if T is the midpoint, that means it's in the exact middle, which means this part and this part are congruent. So ST is congruent to TU by the definition of midpoint, right? That's what a midpoint tells us. The two parts are equal. Okay, well, it tells us that they're congruent. But if they're congruent, that means they're equal, because that's what congruent means. All right, now how do I go ST equals TU to 7x equals 3x plus 20? Okay, well, ST is this segment here. And guys, you can see this segment is equal to 7x. So what we did is we substituted in for 7x. And TU is right here. And we substituted 3x plus 20 in for this TU. Okay, so that would be the substitution property of equality. All right, now we're going to use the subtraction property of equality. Well, what are we going to subtract? Well, we could subtract 3x from both sides of the equation. So what we're left with is 4x equals 20. So that's kind of a subtraction slash simplify. And then how do we go from 4x equals 20 to x equals 5? Well, we divided both sides by 4. So we used the division property of equality, and then we simplified it to x equals 5.